could we start out with introducing yourself, kind of what you do, as far as your position, your educational background, stuff like that?
Karen Launchbaugh. I grew up as Karen Mastel on a little sheep and cattle ranch in western North Dakota, where it's very cold and very dry. So it was short grass prairie, intermediate prairie. And I don't know why my brother and sister didn't care for the ranch all that much, but I loved it. I just all the time was outside walking. It was a small place, but I got to work with animals, got to learn about the land. So even in high school, I was on the range team, and I did the range camp and things like that. So for me, I started out really loving range and wanted to know a lot more about it.
Mm-hmm.
And then I went to, fortunately, North Dakota State had a good range degree, so I went there because I was the other side of the state, but I got a degree in range. And at the end of that, I thought, how am I going to tell ranchers what to do? Because I felt like I didn't know anything. Sometimes that happens. You know, when you learn a lot about something, then you realize how little you know. So that's where I was. I went on for my master's degree in Texas. Wanted to see some different country, and boy, did I see some different country.
Yeah.
I was on a ranch just a few miles from the Mexican border. And so that was where my master's degree was. I worked as a research person after my degree there and worked with the experiment station.
Okay.
And then had the chance to come and learn about animal behavior, which was something I've always been interested in. And that was at Utah State, and that's where I got my PhD.
Okay.
So that's my whole academic career.
Sure. So my name is Rachel Mitchell. I am an assistant professor in the School of Natural Resources and the Environment. In terms of background, I actually did my undergraduate degree here in the College of Agriculture, getting a bachelor's in veterinary science, and then did a PhD at the University of Washington in ecology. After that, I spent some time doing a postdoc in North Carolina, looking at sandhills ecosystems and longleaf pine forests there. Spent 5 years working at Northern Arizona University, and then now have returned back to the University of Arizona, and I'm really enjoying myself here.
My name is Brad Schultz, and I work for the University of Nevada Cooperative Extension, off campus, community based in Winnemucca, Nevada. I'm a natural resource specialist, rangeland ecology and management background. So I pretty much deal in all issues range across Nevada, do some work in the adjoining states periodically with some colleagues, and then do some international work the last 12 or 13 years as well. My educational background, I got a bachelor's degree in, it was called Range and Wildland Science in 1983 from the University of California at Davis. Every school seems to have their own unique name for these programs. Took a year off, went back to graduate school in 1984 at the University of Nevada, Reno, was there 3 years, graduating in 1987, once again in range. And I did a thesis there looking at the size, age, density dynamics, population structure of curlleaf mountain mahogany in western and central Nevada. So a lot of time counting tree rings, measuring the size of trees, and looking at the relationships.
What are some current projects that you're working on here?
Well, you know, of some of them, I guess probably right now I'm doing two of the most, I think, consequential projects I've ever done in my life, which is pretty cool.
Mm-hmm.
One is I've been working with livestock grazing and how that affects sage grouse, because sage grouse occupy the sagebrush steppe, which is the largest ecosystem in North America. It's very important to ranchers. And so we need to know how to use grazing to minimize damage to grouse or maybe even enhance grouse habitat. So that is the end of a 10-year study. We are writing up work now, and it's pretty exciting because it turns out that cows are certainly not detrimental at all to sage grouse. So that was, I've been working on sort of livestock wildlife interactions in a few small ways, and that's a big one for me. And the other is our targeted grazing project. Targeted grazing is something I've done a lot too,
Mm-hmm.
and that relates to the grouse, but also to weeds. I don't have any weed projects right now, but the really exciting thing is the virtual fence project.
Mm-hmm.
It's exciting because the project here at the U of I is so different than the commercially available product.
Mm-hmm.
And we're trying to make it really rugged, really useful on ranches. So it means that I get to work with ranchers a lot and get to work with cows.
Yeah, we're working on a ton of stuff. So we have our longest running project right now is still located up in Northern Arizona University, and we are working on some vegetation response to fire after the museum fire, which happened in 2019. And the museum fire was a small fire that happened just about a mile north of Flagstaff. It was accidentally ignited during a forest restoration project. So, one of those just terrible circumstances. They were trying to thin the forest and the machinery was hot and there was a smolder and nobody noticed it and it erupted into a fire. But the cool thing from our scientific perspective about that fire is that it burned at low, medium, and high severity. So we're looking at how the forest vegetation is responding to those different severities to try to understand how recent fires, which tend to be at higher severity, are changing how forests recover. We're also looking at an invasive plant that I know, Doan, you're really familiar with, which is stinknet. This is a plant that invaded from South Africa into California and has recently, in the past couple decades, moved into Arizona. And it's kind of unusual in that it's moving into a warmer, drier location than where it evolved, and that's not super typical. And it increases fuel continuity. So it's a real concern to desert ecosystems and then land users in the Southwest. We also look at how native plants respond to drought. So we've looked at native grasses and native forbs to understand how those plants are going to deal with hotter, drier futures. And in case I didn't mention it before, but our research is very focused on plants.
So probably the biggest one I got going on these days is a repeat photo study up in the Santa Rosa Mountains, northern part of Humboldt County here. From the Forest Service, I picked up somewhere between 4 and 5, well, close to 500 photos. Some of the more recent ones, a few are from the early 1990s. Most are from the 1970s, 1950s, going clear back as far as about 1914. And in the last about 6 years, I've retaken about, I think the other day I figured out 424 of these I've relocated. One of them came with a geographic coordinate. At best, I usually got just an allotment name, maybe some segment of the allotment or some drainage. And so it's been a lot of time finding those photo points, retaking those photos, and I'm starting to get into the interpretation, the amount of vegetation change, landscape change that's occurred. Sometimes as few as 30 years, but definitely over 100 has been phenomenal. And most of it very, very positive. We all kind of learned that things were degraded at the turn of the last century, but often I think we really don't understand how degraded things were and how far we've come and how much better things are in a lot of places. So in addition to that, I've had a fairly large international component the last 13 years. Still working on it some. A lot of it's been funded by the U.S. Forest Service international programs. It's taken me to 7 different countries from Morocco and Kenya and Africa, all across Central Asia. In recent years, largely Uzbekistan. And it's been a lot of grazing management education. I do a lot of teaching on the basics of plant growth, development, physiology, interaction with a grazing animal. We've also done workshops and short courses in these countries. A recent one this year was looking at nonlinear ecology in Uzbekistan, where I use sage grouse and some of our sage grouse issues here as a model for teaching the concepts of nonlinear ecological thinking. And I also interact with their cadre on an international seminar they do most years, where they bring people in from around the world, about 14, 15 at a time. And we spend 3 or 4 days in Nevada as part of their 2-week seminar. I'm involved with a lot of collaborative planning groups. Some of these are dealing with grazing management, some sage grouse issues, some have been wilderness issues, releasing wilderness study areas or turning them into wilderness areas so they're not in limbo like they have been the last 40 or 50 years. Generally bringing the technical side, the science side to these discussions and making sure it's interpreted properly. I've also had a big project for a number of years that I'm starting to wrap up on noxious and invasive weeds on our rangelands in Nevada, looking at the 25, 26 priority species, different methods of control, their basic biology, plant physiology, root dynamics, how that interacts with herbicides, chemical flow through plants so that they reach the appropriate locations, and then some of the other non-chemical control methods and how to integrate these. Um, and then another big thing I've done for quite a few years, and I'll be starting on here in a couple of weeks, is that I do a statewide forage loss assessment for the Farm Services Agency for one of their insurance programs, where I integrate all the precipitation data for the last year across the entire state by elevation and region of the state. Um, Plug it into some predictive equations on biomass production and come up with some type of estimate of what the forage production has been and how it's varied spatially across the state, so they can use that information for any insurance purposes or insurance claims that might be filed for forage losses. So,
Are all of these through UNR, or is it kind of contracted as well?
no, it's all part of my day job. Um, it's based on relationships I've built over the years, contacts I've made, uh, needs assessments we've done in the state, um, issues that come up or that are priority locally or regionally. Just a lot of different factors going into deciding what you're going to work on, because there's always a lot more to work on than you have time to do.
And for you, how did you get involved doing international work?
I was in the right place at the right time. And it's really an example of how little can take you so far. And by how little, um, at that point in time, extension in Nevada was a lot larger, and we had a formal um, range management education program, great grazing management, called it our Nevada Range Management School. And as part of that, I taught about an hour and a half segment on plant growth, development, physiology, and grazing. And it was interdisciplinary. We had a woman from the Forest Service as part of that, and she had recently moved to Idaho in about 2011. And USDA brought several Moroccans to her office in Idaho, and she'd mentioned this range management school and asked me for 6 slides out of the 60 some of that program that could best illustrate it. And those 6 slides have turned into 13 trips to 7 different countries teaching this concept. So, you don't know how something small, the opportunities it's going to create for you, and then the paths it's going to lead you down.
What was your kind of professional exposure to range?
I think maybe two things. One is I just think some people have just a predisposition to it.
Mm-hmm.
Like I say, my siblings, they could take it or leave it. They neither of them worked into agriculture, but me, I was just taken by the wide open landscapes, and I guess I was really amazed that there could be so much diversity where we had very little rain, like 10 or 11 inches a year. And I just couldn't believe that it could be so diverse and that people never looked down. They didn't realize that. I will admit, I was first taken by wildflowers. Oh, how could those beautiful flowers make it in the range?
Mm-hmm.
So that was my first fascination, was like, oh my gosh, there's so much here, and it's such a hard thing for a plant to make a living. Of course, I was interested in cows and sheep, and that was just easy. Everybody likes lambs and calves, and that was really my start too.
Mm-hmm.
But I really got interested in science also there. I just kept asking questions, things like the why is it different on this side of the fence than this side of the fence? Just things like that. And then I started, like, even my science fair project was on grass.
Mm-hmm.
And so that was kind of the other connection to me, was, first the love of the land, and then trying to figure out, well, how Mother Nature's doing that.
That's a great question. So when I started academically at the U of A, I'm a first generation college student, so I didn't really know what I wanted to do. So I tried out a bunch of different types of research. I worked with birds, I worked with insects, and then I ended up working a lot in plants sort of inadvertently because they support birds and insects. And what I started noticing everywhere I went, there are no more ecosystems, or at least largely, there's not a lot of ecosystems that aren't sort of also used by people. So I started working in Pacific Northwest prairies. Those had largely been converted to farmland or to pastures for raising livestock. On the East Coast where I worked in the Sandhills, that was a military base that had been used for military work and also was a habitat for an endangered bird. So human land use is a really big part of ecology generally for a lot of places. And what I like about rangeland ecosystems is they're kind of defined in part by what you can't do with them, which is they're often too dry to grow crops. They're not woody enough to raise timber. And so they get used for livestock, free range livestock production across the Southwest and the West generally. But that's just a small part of what those ecosystems are. So I like rangelands because they cover just a diverse set of different plant communities and species, but there's a really important human component. They're important to people, they're important to our economy. So it's a really cool, complex ecosystem, or socio-ecological system, really. And that's what I like about working as a range faculty and working in rangeland sciences.
Going to be kind of a long answer here.
That's
Um,
okay.
I grew up in the foothills of Southern California, had cattle and sheep on the hillsides at various times of the year. So I've seen range from when I was a little kid and had no idea what I was looking at. It was just the foothills. We went out hiking out there, shooting the BB guns and so forth. And I'd expressed an interest to people I knew that, everybody knew what forestry was, or what forests were at least, and everybody had an idea of wildlife. So that's where my interests were. And I went to visit a friend when I was 18 in Prineville, Oregon, and his dad knew I was interested in this kind of stuff. So he took me to meet people he knew at the Forest Service and the BLM, State Fish and Game, and some other agencies. And while I'm talking forestry and wildlife, every last person I talked to said, well, you might want to consider this thing called range management. And then they explained what it was, which is kind of, I've been looking at that stuff my whole lifetime growing up without knowing what it was. So I looked into it further, and the rest is kind of history.
That's cool.
Once again, it was just one of those small things that you didn't plan on, completely altered the trajectory.
Did you ever like envision yourself in like the role you're in today?
Know if I foresaw myself necessarily in a range program. I think so. When I came as a student to the university, I had like no idea I didn't know what being a professor meant, or that it was a job that you could do and how to get there. And I was lucky that I had great professors advising me while I was here, helping me understand that if I wanted to become a professor, I needed to do research and I needed to go to graduate school. And what I learned while I was at the University of Arizona is I liked the big questions. I'm not really, some people really like certain organisms or they like certain ecosystems. I really just like the big ecological questions. And as in my lifetime, I think those questions have moved from some really theoretical questions to these really applied questions of like, ecosystems are changing due to anthropogenic change. People rely on those ecosystems. And I think range programs and the School of Natural Resources and the environment particularly let us answer those questions. So I don't know if I envisioned myself here. And I certainly never thought it's very unusual for you to get a professor job at the place you did your undergraduate degree. I never dreamed I would get back to Tucson. I'm really glad that I did. But I like this kind of department where we use science to answer questions that help people and ecosystems. I wouldn't have guessed it when I was 18 coming to the University of Arizona, but I'm really glad that I found my way here. And I did know I wanted to be a professor. I just didn't know, I had no idea what that would.
It was just kind of in my blood. Everything, all aspects of it just kind of flowed naturally with me. But what I've always found of interest and probably really keeps me involved with it is the complexity. Range issues, rangelands, highly variable. They're very complex. The ecology is complex. The social, political dynamics, the social, political, ecological dynamics, their interactions are complex. And I think it's that complexity that's kept me intrigued and engaged. for me and my mindset and what I find rewarding when I get in on an issue that's multidisciplinary, like to really get to the crux of the issue, to find a solution, you need information from 4 or 5, 6, maybe 7 or more disciplines. Going into those, often ones I'm not familiar with, finding the relevant information, seeing how it all fits together to come up with a better solution, not the perfect solution, you never get completely right, but something better. It's been, for me, a very challenging part of my career from day one. So I would say it's being able to address that complexity, um, be creative, kind of sometimes get paid to take risks that others don't get, to have the opportunity to go down rabbit holes, um, that are often quite fruitful if you spend enough time in them, and be able to put that information together and then in a way that people can understand, where it's never been presented to them in that way before, but now you got to make it understandable as well. And so developing those written and verbal communication skills.
My goal was always to go back. I didn't think I would ever have a ranch because our ranch was really small. But I wanted to work with ranchers. I knew I wanted to do that. So that was my first goal. And that was why I went on for my master's, just because I thought maybe I'd have something to offer. And when it wasn't, and I always was interested in science, which working as an extension agent, which would have been great, or with the NRCS, were kind of my main goals. I knew I would need to know about science and then I'd have to apply it. So that was really win-win. But when I started doing research for other people, I thought, I can do this. It was when I realized that being a scientist wasn't this big thing up on a pedestal. It was really pretty easy. You just had to ask good questions and be really disciplined. So then I started getting into science, and I'm sure it was animal behavior that drew me in the most, because I'm just very interested in why animals do what they do. It'll for the end of my life, I'll just be interested in that piece of it. So both of those things, where I grew up, but then science. And no, I didn't think I'd ever work for a university until I was well into my PhD. Even though I had been doing teaching, I'd been working at range camps, I'd been being a teaching assistant in college, both as a graduate and undergraduate. I liked that, but I just didn't think I had what it took. And I remember I sat down with my graduate committee in my PhD, and I said, well, I don't know, guys. I really think I'm like to maybe do what you do. And they were like, they just laughed. They said, oh, you'd be way better than us. And that, just their confidence in me just made me think, oh, well, maybe you guys aren't, like it's not impossible. Maybe I could do it. So that was not till I was in my PhD that I thought maybe I could work at a university.
Yeah.
What's your favorite aspect of your position?
Now you're asking a 64-year-old brain to think on the spur of the moment. Probably the two, and they're actually at the beginning and end of my career here. This repeat photo study on the Santa Rosas, where I can integrate fire history, grazing history, basic plant succession concepts, looking at stuff that's old and how it looks today, and thinking the processes through of why it looks like it does now, why it's changed the way it has. It has been quite enjoyable. And then going back to the very beginning of my career, my master's thesis, where I looking at the ecology of curl-leaf mountain mahogany, it wasn't really a well-studied project or a well-studied species. And I was asked if I wanted to do it. It involved counting tree rings, and I thought, sure, tree rings. I've looked at tree rings before. Everybody's gone to a visitor center and they've seen tree rings on a redwood or something. It's a little bit different with mountain mahogany. It was 15 months looking through a microscope, 10 hours a day, because in places the average tree ring width was 0.1 millimeter. But that project really taught me the value of observation and being intimate with the data. Because if someone had just handed me that data, I have no doubt my conclusions would have been entirely different than actually doing the work myself, making the observations I did out in the field, and being able to tie that back to the data I collected. And it actually made really good sense in the end, even though you were quite perplexed throughout the whole project. but it really set me on a path of understanding the need to understand the fine details, um, be patient, and not be afraid to work on something really complex and challenging.
The thing that I love about range is that it's so underappreciated. Now that sounds weird to love something that is like more easily defined on what it's not than what it is. People don't really even understand it, but man, it is fun to be involved with people that know what rangelands are, and so we're a pretty small group, and there's lots of room for new ideas and new people. But we are the ones we need to. I don't know, I hate to say save the range, but we need to be invested in the range and the people that live in it, because people will drive by and not even notice it's there. So someone has to stand up for the range, and so that is my last piece of advice: is stand up for the range and find other people that do. It's really, really rewarding. Uh, you know how it is being able to go for a walk out on the land and know these critters and know these plants and feel at home. And we need people that understand that and will stand up for the range, because I think rangeland is one of the best hopes for keeping our planet healthy, because we can be working, our lands can have working landscapes, it can have communities and people, and healthy grazed land is going to be a key. Carbon, pollinators, fire, all the things that are causing challenges can be solved with really healthy working landscapes. So I don't know, I don't think, not until people get into range a while do they realize how important this ecosystem is and how many solutions we have for the future. So I'm excited, and it's going to be the rest of my life. I won't lose that fascination, because it's not going to change. It's not like we're going to figure it out and we can go on to something else. It's always going to be there.
Oh, that's an easy one for me. So I really like mentoring students. So I would not have gotten to where I am without mentorship. So I mean, like I said, I came here, I had no idea what I was doing, didn't know what classes to take. I didn't know how to get involved in a way that would make me competitive for grad school. And so good mentorship is what got me where I am today. And so I try to continue doing that for young scientists. It's a complicated career field. There's things you can do with a bachelor's, there's things you can do with a master's, there's things you can do with a PhD, and none of those paths are right for any one student at any given time. So I really like mentoring students, helping them learn how to do research, helping them navigate, early adulthood and all the choices that come with it. So that for me is my favorite part of this job.
Do you have any advice for young professionals entering the field?
Yeah, any of us that have been around have, I won't necessarily call it wisdom, but we've experienced things and there's information we can pass on. And I think probably first and foremost is just plan on lifelong learning. You're never going to stop. The world changes so fast these days. There is so much information. Um, to stay on top of things, to stay relevant, you're going to be learning day in and day out. And then you got to kind of figure out of all that, what's important and what is not important. And that's kind of a skill you learn with time. Stay open to possibilities. You're going to have opportunities come in front of you that you could have never expected. And, it's okay to have a plan and an idea of where you might want to end up. But remember, it's just a plan and an idea. It may or may not be the best one, and you don't know what kind of good things can fall in front of you. So stay receptive. Every place you go, someplace different, find a good mentor, someone that can, really teach you something, and then just bluntly ask them, what do I really need to know that no one is telling me about to get better at this? Learn the fine details. Anything you're working on, the devil truly is in those details. If you learn the details, understand them, how they work, you'll come up with better solutions. Always ask yourself, what can I do today to make tomorrow better than yesterday? We're not really going to solve the world's problems, but we can always make tomorrow better than yesterday was. And those little successes over time are usually personally satisfying, but ultimately develop into some large scale successes. And then kind of a corollary with that is, we're never truly right on a lot of stuff, but we can be more right tomorrow than we were yesterday by really understanding those details and that continual lifelong learning. And that's where you really want to get, being less wrong tomorrow than I was yesterday. Develop strong communication skills in both written and verbal. A lot of ideas that you want to convey are complex. You only get sometimes one, maybe two shots to do it, especially if you're in a large group. And so having those excellent communication skills to get those complex ideas across succinctly and clearly will make you a lot more successful at what you do. Be an excellent listener. All learning, all improvement comes initially with good listening skills. And it's hearing what people are saying, what they're not saying, and what they think they mean to say. Because often they don't get what they really want to say said the first time or two through. And listening and asking yourself, this is what I'm hearing, but is it what I'm really supposed to hear? And then finally, in range, you're always dealing with people, and you go to school, you're learning all the science. At best, science is probably 49% of the solution to any problem, because you're dealing with people, different ideas, different philosophies, different cultures, different values. They're going to be at a minimum 51% of the solution. And how you mesh those two together is how you're ultimately going to get to some place that's agreeable or acceptable to the majority.
Yeah, I think the most important piece of feedback I ever got, and that I try to tell students, I think you've been the recipient of this advice, is to try different things, right? So, when I was an undergrad, I started out thinking I really like birds. I like watching them. I have a pet bird. And I thought I wanted to research birds. And then when I started working with them, I found that it really wasn't like the questions were interesting, but working with them was kind of a pain. And they're breakable and they die. And I didn't like that. And I tried insects, and insects were kind of interesting. And it took me a couple tries of research systems, but then at the same time, I was working in a veterinary clinic trying to decide if I wanted to become a veterinarian. And I groomed dogs for a while and trained dogs. And so I was trying out all kinds of things to find out what I really wanted to do with my life. And you never have to sort of settle on a path just because you're trying something out. So trying out all of the avenues that you possibly can. Maybe you don't think you are interested in research and then you do it and you really like it. Or maybe you think you really want to be a researcher and you try it out for a summer and you hate every aspect of it. You can't know those things about yourself until you try them. So when you are an undergraduate or early graduate student, trying out as many different things as you possibly can, trying living in new places, trying eating new foods, just learning a lot about who you are can really help you know your strengths and weaknesses when it's time to really get going with your career after you graduate.
Yeah, it's a way different world now than it was when I was going through. We learned the principles. We really were under this illusion that we could get books and learn principles and do good work. The world is changing so fast, and our science is changing fast. What we know about the world is. So my advice is be curious. I don't know how you instill curiosity into people. Mm-hmm. I just know that of the students that I have, some are they always have questions and they're always figuring out a way to answer them. Mm-hmm. And I see those students go out into the world and continue to ask questions and read books and call me and figure it out. And they're some of the best ones. So my advice is be curious. Mm-hmm. And you don't have to be a scientist. You just got to be curious and start to look around and say, what's happening here? So the next generation, I think, has to realize that all these principles are important. We got to have a foundation, but we don't know. We don't know how it's all fitting together. Mm-hmm. So live, learn, be curious.